Welcome to microScope, where we zoom in together to make sense of the world. Today, we're zooming in on something extraordinary: the world's greatest scientific megaprojects, machines that stretch across nations, instruments built to look back to the beginning of time, computers that simulate the building blocks of reality, and reactors designed to recreate the power of the sun right here on Earth. These projects aren't just achievements. They're humanity's boldest attempts to push beyond the edge of what we know and into what we hope to discover. And once you see them under the microscope, you'll never look at science the same way again. Let's begin. 1. CERN. Beneath the border of Switzerland and France lies the largest machine ever built, the 27-kilometer Large Hadron Collider. It accelerates particles to 99.999999%, the speed of light, then smashes them together to recreate conditions a trillionth of a second after the Big Bang. CERN gave us the Higgs boson, confirmed the structure of matter, and continues probing mysteries like dark matter and hidden dimensions. Interesting fact: its superconducting magnets are cooled with liquid helium to minus 271 degrees Celsius, colder than outer space. CERN isn't just a collider. It's a time machine for physics itself. If you're enjoying this exploration of humanity's most ambitious scientific creations, consider liking the video. It helps microscope reach more curious minds just like you. Let's continue. 2. ITER. In southern France, thousands of scientists are building the most ambitious energy experiment ever attempted, ITER, a nuclear fusion reactor. Fusion promises nearly limitless clean energy with almost no waste, but requires heating hydrogen plasma to 150 million degrees Celsius, 10 times hotter than the sun's core. The challenge isn't just scientific, it's engineering on an unimaginable scale. Massive magnets, perfect vacuum chambers, global coordination. If ITER works, fusion could rewrite the energy story of civilization. 3. The James Webb Space Telescope. Floating a million miles from Earth, the James Webb Space Telescope looks back farther than any instrument in history. It can detect light that traveled for 13.5 billion years, allowing us to observe the first galaxies forming after the Big Bang. Webb's golden mirror, coated with 48 grams of gold, must remain colder than minus 233 degrees Celsius. It's so sensitive it could detect the heat of a bumblebee on the moon. This telescope isn't looking at space, it's looking at time. If you're enjoying this exploration of humanity's most ambitious scientific creations, consider liking the video. It helps microscope reach more curious minds just like you. Let's continue. 4. SKA. Across remote regions of South Africa and Australia, thousands of antennas are forming the Square Kilometre Array, the largest radio telescope ever built. Once fully online, SKA will generate more data per day than the entire global internet. It will map cosmic magnetism, study black holes, explore the early dark ages of the universe, and search for potential extraterrestrial signals. It's not a telescope, it's a planet-sized ear listening to the universe. 5. Artemis. NASA's Artemis program is not a repeat of Apollo. It's the start of a lunar infrastructure, human landings, a moon-orbiting space station, a permanent base, supply chains from Earth, the technologies needed for Mars missions. This is the first step toward a civilization that lives beyond Earth. The moon is becoming our test bed for life on other worlds. 6. Quantum computing. Quantum computers operate not on bits, but qubits, units that can be 0 and 1 simultaneously. This lets them solve certain problems that classical computers can't even begin to approach. Global efforts by Google, IBM, and China are pushing boundaries. China built a quantum-secure network impossible to hack traditionally. IBM aims for a 100,000 qubit machine. Google achieved quantum advantage in experiments. Quantum computing isn't just faster. It operates under different laws of physics. 7. AI supercomputers. Machines like Frontier, Aurora, and Summit are now among the most powerful tools in science. These supercomputers can model climate systems, protein folding, atomic interactions, virtual universes, new medicines and materials. Frontier became the first exascale computer, capable of a billion operations per second. They are the laboratories of the future. Physics, biology, and chemistry recreated in code. 8. Deep sea exploration. While we dream of space, our own planet holds mysteries even more extreme. Over 80% of Earth's oceans remain unmapped, unseen, and unexplored. Megaprojects in deep-sea robotics, autonomous submersibles, and seafloor observatories are discovering ecosystems that live without sunlight, life near boiling hydrothermal vents, geological formations taller than skyscrapers, microbial worlds with clues to the origin of life. We know more about Mars than we do about our own oceans for now. 9. Genomics megaprojects. The original Human Genome Project cost $3 billion. Today, a full genome can be sequenced for under $100. Now, new megaprojects aim to go further. The Earth Biogenome Project plans to map all 1.6 million species on Earth. Advances in gene editing, like CRISPR, could cure genetic diseases. Genomic databases power future medicine, evolution research, and biodiversity protection. These projects are turning biology into information science. 10. Climate and geoengineering megaprojects. Humanity is now building massive technological systems to stabilize the climate. Giant offshore wind farms, mega solar deserts, carbon capture plants, direct air CO2 removal, research into cloud brightening and atmospheric cooling. The world's largest carbon capture plant in Iceland can remove 4,000 tons of CO2 per year. Small, but rapidly scaling. These projects may become essential tools in managing Earth's future. 11. Why megaprojects take decades? Scientific megaprojects don't move slowly because of inefficiency. They move slowly because reality is complex. Before a single bolt is tightened, years are spent on theoretical models, simulations, safety systems, failure scenarios, political agreements, funding commitments. At CERN, even a tiny miscalculation can shut down experiments for months. In fusion reactors, one unstable plasma event can damage equipment worth billions. In space telescopes, there is no repair once they launch. These projects must work the first time. That's why megaprojects operate on a different timeline than consumer technology. They aren't designed for speed. They're designed for precision, reliability, and discovery. In many cases, the technology needed doesn't even exist yet, so scientists must invent the tools while building the project itself. Megaprojects don't just produce answers. They produce new materials, new software, new engineering methods, and entirely new scientific fields along the way. The long timeline isn't a weakness. It's proof that humanity is attempting things at the very edge of possibility. 12. The hidden impact. Most people never visit a particle accelerator or a quantum lab, but the effects of these megaprojects quietly shape daily life. From CERN came the World Wide Web, advanced medical imaging, and particle therapy for cancer. From space programs came GPS, satellite weather prediction, and global communications. From genomics came personalized medicine, rapid vaccine development, and early disease detection. Even fusion research has already delivered ultra-strong magnets, breakthroughs in superconductors, and advanced energy storage concepts. Megaprojects act like knowledge engines. They generate tools and discoveries that spill outward into society. What begins as a question about the universe often ends as technology in your pocket, medicine in a hospital, or infrastructure holding civilization together. These projects remind us of something essential. Science is not distant or abstract. It is the foundation of the modern world, built patiently, collaboratively, one impossible machine at a time. Science isn't just something that happens in labs. It happens in machines the size of cities, in telescopes floating in deep space, in oceans deeper than Mount Everest, and in computers that think in quantum states. These megaprojects reveal something powerful about humanity, our drive to understand, to explore, and to build, even when the challenges seem impossible. Thank you for watching. If you'd like to keep exploring the hidden systems shaping our world, please subscribe. This is microScope. Clarity starts with a closer look.